In this video, we're going to go ahead and talk about percent error, what it is and how it's used, and we're going to do some practice problems together. So let's go ahead and get started. You are going to need a calculator, so you want to have that nearby or handy for you to easily access. So what is percent error? Percent error is a calculation of how efficient your lab technique is. There's a few different steps to find the percent error. The first one is to identify the experimental and the accepted yield. So experimental is what the student actually got in lab, and the accepted is what should be the answer, and you would know this by a reference book, the teacher telling you, or by solving. The second step is to use the equation to solve. If we notice, it's experimental minus accepted divided by accepted, and then you're going to multiply times 100. If we notice this, there are two vertical lines here, and that does mean absolute value, so the number will always be positive. All right, so let's go ahead and do some practice problems together. The first problem says, Joshua uses his thermometer and finds the boiling point of ethyl alcohol to be 75 degrees Celsius. He looks in a reference book and finds that the actual boiling point of ethyl alcohol is 80 degrees Celsius. What is his percent error? So the first thing we want to do is identify the experimental and the accepted. What is the experimental? What did Josh actually get in lab? So we can see that the experimental is 75 degrees Celsius and the accepted is 80 degrees Celsius. We know the accepted is 80 degrees because that was what was according to the reference book. So let's go ahead and solve this problem. Here we can see that it's already set up. I always like to write my formula, experimental minus accepted divided by accepted times 100. And I have it set up already. I like to label all of my variables. Experimental is 75 degrees Celsius. That's what Josh got. Accepted is 80 degrees. That's what was from the reference book. So now I can go ahead and use this equation and plug it in. So 75 degrees Celsius minus 80 degrees Celsius divided by 80 degrees Celsius. It is absolute value. And we're going to multiply times 100 because we want a percent. So 75 minus 80 is negative 5 divided by 80, and we know this goes in absolute value, and we can multiply times 100. So negative 5 divided by 80, let's go ahead and do the math. So we have negative 5 divided by 80. And then we know that it was a negative number, so since it's in absolute value, we get positive. Then since we want a percent, we're going to multiply times 100, and you should get 6.25%. Now this is a very good percent error since the number is very low. The lower the number, the better. All right, let's look at practice problem number 2. Practice problem number 2 says, the density of water at 4 degrees Celsius is known to be 1 grams per milliliter. Kayla experimentally found the density of water to be 1.075. So it's a little bit off. What is her percent error? The first thing that you want to do is identify the experimental and the accepted. Which is the experimental and which is the accepted? Here it tells us that Kayla got 1.075 for the experimental, but it's known to be 1. So 1 is going to be our accepted, 1.075 will be our experimental. So we're going to go ahead, use that, and plug it into our equation and solve. So if this is our equation, I have already listed my E and my A. I want you to do that each and every time so that way you can clearly plug it into the equation. So our E is 1.075 minus 1.00 divided by 1.00, and its absolute value, times 100. So 1.075 minus 1 is going to be 0.075. I'll tilt it a little bit. And then we know we have to divide that by 100, its absolute value, and then times 100. So 0.075 divided by 100, divided by 1, not 100. So 0.075 divided by 1 So we get 0.075, anything divided by 1 is itself. We want a percent, so we need to multiply by 100. So 0.075 divided by 1 times 100 will give you 7.5%. So this too is a very low percent error, so they did a very great job with their experiment. The lower the number, the better. If it's a very high number, that means something went wrong in the lab. Maybe it was with the materials, the substance may not have been right, maybe the directions were not followed. However, we want a low number. If you have any questions, please let me know. Please make sure you do your practice problems. Have a great day, guys.